Hey guys, welcome to 3.2, completing the square. Our objective today is to complete a square for a quadratic equation and solve by completing the square, meaning solving quadratic equation. So our goal for completing the square is we will be given an expression now that's in the form ax squared plus bx, meaning there are no c terms. Most of you should remember, or all of us should remember, that a quadratic is always in the form ax squared plus bx plus c. In this case, I will be given this first two term, but there will be no c term. So our goal is to make it in such a way that we have this right here. This is our two formula for completing the square, meaning I have an a term square plus 2ab plus b squared, meaning some one of these terms are going to be square. Then when I just factor that, I will get a plus b squared. So the only difference between these two is that whatever number is in front of my middle term, that tells me what to go there. So again, when I multiply a times b, whatever those numbers are, and I times it by 2, I will get my middle number, and then I can simply factor this. So when I'm given no c term, all there is two simple steps that I need to do. First step is take half of the x coefficient and then square that number. So let's look at an example. I am given x squared plus 6x. My direction says to solve this quadratic by completing the square. The first thing I need to do is take half of my middle term, which is 6, so half of 6 is 3, and then the second step says square this. So 3 squared is 9. Once I've done these two steps, all I need to do is rewrite this as x squared plus 6x plus 9. Now, most of you know how to factor this. You can do a equals, b equals, c equal, or in 30 seconds or less, we can go ahead and rewrite this as x squared plus 6x plus 3 squared. All I'm doing is taking the square root of this number. The reason why I did that is because I know this is an invisible 1, so I know the number up here will be a 1. This will be a 3, and I'm going to check it. 1 times 3 is 3, and then if I take that 3 and multiply it by 2, I get the middle number. And remember, that's part of our equation right up here where it says 2ab. So I have something that looks like this in red. I know I'm going to take my a number plus or minus, depending what number is in front of my middle term, my b, and then I'm going to square this. So going back to here, my a in this term is x, and I know my b is 3, and it will be something square. Now, what's in front of my middle number? That's a plus, so I know this is going to be a plus, and this is my answer solved by completing the square. The regions are very, very specific. If they want you to use this method of dividing by 2 and square it, they will specifically say completing the square. Let's see how this works again. So again, my middle term is 12. Take half of that, which is 6. And then I want to take 6 squared, which is 36. And I'm going to rewrite this. X squared plus 12x plus 36. And then just for my own purposes, I am going to rewrite this as x squared plus 12x plus 6 squared because I took the square root. Oopsie. I took the square root of that. So then I know this is a 1 and my b is 6. So I say 6 times 1 is 6. And then 6 times 2 will give me 12, which is what I wanted. Once I do that, I know it's going to be x. They're going to be a 6, and it's going to be something squared. Now, what goes here? What's in front of 12x? It's addition, and that means addition goes in the middle. There you go. I just factored this quadratic, x squared plus 12x, by completing the square. Now, one more. My middle term is 10. So 10 divided by 2 is 5. Then I'm going to square it. 5 squared is 25. And I'm going to rewrite this now. Y squared minus 10y plus 25. Just so I can check, that I have this in completing the square form, I'm going to write this as y squared minus 10y plus 5 squared, and this will always happen once I'm doing these two processes. Again, this is going to be my invisible 1. This is 5. 5 times 1 is 5, and then 5 times 2 is 10, which is what's my middle number. So I go ahead and write y, and I know it's going to be a 5 squared. What goes here? What's in front of the 10? Perfect. Subtraction goes in the middle. And there you go. That's my answer. Now, what happens when I am given a C term? So steps to solve a quadratic equation by completing the square when given an equation in the form ax squared plus bx plus c equals 0. So if the quadratic does not factor, meaning I can't do my a, b, and c, move the constant to the other side. I'm going to work with the x squared plus x side of the equation and then complete the square by taking half of the coefficient and squaring it. Then I'm going to add the number that you got to the square to both sides of the equation, simplify my trinomial, take the square root of both sides and solve. Yes, I know it seems like a lot, but look how simple this is. The first one we're going to do will be step by step. Okay? So, solve the following by completing the square. X squared minus 4x minus 7. First step says to move the constant to the other side. So, I want to take this minus 7 and move it over. So, all I'm going to do is add 7 on both sides. When I do this, I get x squared minus 4x is equal to 7. Now complete the square by using the coefficient of x. So in this case, the coefficient is 4. So what I'm going to do is 4 divided by 2, which is just what we did on the previous examples, is 2. 4 divided by 2 is 2. And then I'm going to take the 2 square, which is 4. That's me completing the square. Once I do that, it says I'm going to add that number to both sides. So I'm going to have here x squared minus 4x, and I'm going to add 4 to both sides. That's my keyword, 7 plus 4. Then what I'm going to do is just simplify my trinomial. So this becomes x squared minus 4x plus 4 is equal to 11. Good. Now that I have this, I know that this is a perfect square trinomial. Good. So this will actually be worked out to be x minus 2 squared is equal to 11. Okay, how did I get this x minus 2? So really quick, as a review, this can be written as x squared minus 4x plus 2 squared. And I know it's 1 times 2 is 2, 2 times 2 is 4, so good. I know it's going to be an x, it's going to be a 2, and something squared, just like the examples before. Here in front of my 4x it's minus, so minus goes in the middle. Once I've done this now, it says step 5 says to take the square root of both sides. So I'm just going to rewrite what I got. X minus 2 squared is equal to 11. Take the square root so I can get rid of that square. This is cancel, and I'm left with x minus 2 equals to the square root of 11. Now remember, actually, we don't even need the parentheses here because we already got rid of the square. So x minus 2. Now it says the last step says solve. So what am I going to do? Add 2 on both sides. Perfect. This is cancel. I'm left with x is equal to 2 plus or minus the square root of 11. Remember the square root from when you're using the quadratic formula, you can always get a plus or minus. So now that you have this, your answer choices are going to be split up. Remember, you have two answers. You have x is equal to 2 plus the square root of 11, or x is equal to 2 minus the square root of 11. And these are going to be your two final answers. Okay? Now, let's see what's happening next. So, let's see how this works without the step written out. So, the first thing says I'm moving my constant over. This becomes x squared minus 6x is equal to 16. Then I want to take half of this, and let's write that in the corner. Half of this, which is 6 divided by 2, which is 3, and then 3 squared, which is 9. Good. So I'm going to take this number and add it to both sides. So I'm left with x squared minus 6x plus 9 is equal to 16 plus 9. Perfect. Now let's simplify these. I know 16 plus 9 is 25, and I know this is a perfect square where I'm going to get x minus 3 squared. Are we good? Now to get rid of the square, I take the square root to both sides. These are canceled. You're left with x minus 3 is equal to a plus or minus 5. Remember, when you take the square root, you get two answers. Now let's solve. Add 3 on both sides. This is canceled. X is equal to 3 plus or minus 5. So now how do we solve this? I'm just going to come up here and write my solution. So my first solution is x is equal to 3 plus 5, which we know is 8, or x is equal to 3 minus 5, which we know is negative 2. So these are my answers. Okay, wasn't that bad? So again, x squared minus 6x equals 6. We isolate the constant. Then we take half of the x term and square it. And remember, this is what, like the two examples we did in the first. So you're always going to have your x and take the square root of this number. That's what's coming there, and it's going to be square. Remember, the sign depends on what's in front of my middle term. When I do this, I take the square root to get rid of the square. I'm left with x minus 3 is equal to plus or minus 5. Plus or minus because it's a square root. Add 3 on both sides, and then I just solve. Now, for number 2, we have to be extremely careful. So where's number 2 go? Here. This only works for when x squared is equal to 1. So the first thing I need to do is, like always, I want to go ahead and isolate my constant. So I'm left with 2x squared plus 3x is equal to a positive 3. Now I can't do anything because x squared, there's a coefficient in front of there, which is 2. So the question is, how can I make this x squared 1? So that's perfect. To get the x squared by itself, what I'm going to do is divide every single thing by 2. This is cancel, and I get x squared, which is what I wanted. 3 over 2x is equal to 3 over 2. Perfect. Now that I have this, now is where I take my middle term and I divide it by 2. Same thing. So 3 over 2 divided by 2, and you can check this in your calculator, it's 3 over 4. And then I'm going to still do my same thing that I normally do, is square this. You're not sure what this is? Plug it in your calculator. 3 squared is 9, 4 squared is 16. So just like I would normally, is take these and add them to each side. This becomes x squared plus 3 over 2x plus 9 over 16 is equal to 3 over 2 plus 9 over 16. Now that you have this, you know this is my perfect square where I'm going to have x plus 3 over 4 square. And again, I want you to be able to put this in your calculator. To get a fraction on your calculator, you go to CTRL and the division sign, and something should pop up like this. Okay? And be able to end that. So I'm going to pause. I'm going to have you pause the video and tell me what this answer right here should be. 3 over 2 plus 9 over 16. Yes, that means you have to get up and go get your calculator if you haven't done so already. Check this out in the calculator and tell me what you get. I will wait. From this, you should have gotten 33 over 16. If you did, excellent work. Now that you have this, now that you have this done, is the same exact thing that we have been doing. Take the square root of both sides. Don't worry about and freak out because you have a fraction. That's cancel. You're left with x plus 3 over 4 is equal to the square root of 33 over 16, which is fine. And then my next step would be minus 3 over 4 on both sides. This is cancel. I'm left with x equals minus 3 over 4 plus or minus the square root of 33 over 16. And now that you have that, you're just splitting your answer. X is equal to minus 3 over 4 plus the square root of 33 over 16, or x is equal to minus 3 over 4 minus the square root of 33 over 16. And these are your two answers. Okay? Just don't freak out when a is greater than 1. Just divide everything. That's all you need to remember. Okay? Alrighty. You know what to do. And guess what? I know you can do this. See ya!